AP Physics, this is summer lesson number 13, and it's on the subject of momentum. So what is momentum? Momentum is the part of Newton's first law that deals with motion. An object that is already in motion wants to stay in motion. Momentum is equal to an object's mass times velocity. The abbreviation for momentum is small p, lowercase p. We write the formula for momentum as P equals mvi, instantaneous velocity. Some books, in fact most books, write the formula as simply P equals mv. You need to use instantaneous velocity, not average velocity, when you calculate momentum. The units of measure for momentum is mass times velocity, so that's kilogram times meters per second squared. So that's just read kilogram meters per second squared. So a 10 kilogram bowling ball rolls at a constant velocity of 2 meters per second. What is its momentum? So the momentum P equals question mark, mass equals 10 kilograms, instantaneous velocity is 2 meters per second. So the formula, it's just simply plug in the numbers and you get 20 kilogram meters per second. B, what is the force? B, there's no force because the ball is moving at a constant velocity. Acceleration is 0 meters per second, and therefore there is no force. The only force occurs when the ball strikes something, then there's a deceleration that causes the force. Compare these two equations and remember the difference. Force equals mass times acceleration. Momentum equals mass times the instantaneous velocity. When an asteroid is traveling through space at constant velocity, it has momentum, but it has no force because there's no acceleration. Once the asteroid strikes a planet, the sudden negative acceleration, slowing down, creates the force. Pulse. A pulse is force times the amount of time it's applied. So pulse equals force times time. The units of measurement for a pulse are the same as for momentum, kilogram meters per second. Pulse is also called impulse. So the amount of pulse needed to stop an object's momentum is always constant. So force times time, which is pulse, equals mass times velocity, which is momentum. It also could be the pulse is the amount of force times time to create a momentum, to get something to speed up and to have a momentum. So Ft equals P equals momentum. So how much force would it take to stop a car with a momentum of 15,000 kilogram meters per second in 10 seconds? So you're looking for a force. The MVI, or the momentum, is 15,000 kilogram meters per second. The time is 10 seconds. So you can simply write the equation Ft equals MVI. Now you do a little algebra on that, and you're going to divide both sides by t. And you end up with force equals mv, the momentum, divided by time. So now you can come back and plug in the numbers, and you get 15,000 over 10 seconds. So the force would be 1,500 newtons of force would be required to stop that car in 10 seconds. A soccer player shoots a ball at the goal with 15 kilogram meters per second of momentum. So in case number one, the goalie can punch the ball away by using a lot of force for a short amount of time. So to take that 15 kilogram meters per second of momentum out of that ball, the force times the time have to multiply to 15 kilogram meters per second. So he could punch the ball with a lot of force. That's 150 newtons times a very short amount of time, 1/10 of a second. That would be punching a ball. Or in case number two, the goalie can catch the ball by letting the ball hit his body softly. He does this by using a small amount of force spread out over a longer time. So the force is only 15 newtons in the second case, and it's spread out, instead of in just 1/10 of a second, it's spread out over an entire second. And that's how you catch a ball. You let your hands or your body give on the ball as the ball hits it. That spreads the force out over time, and that's how you can catch a ball, as opposed to letting it bounce off your hands or punching it away. Conservation of momentum means that when two objects collide with each other, the total momentum of both objects after the collision is the same as the total momentum before the collision of the two objects. Conservation of momentum is expressed as, before the collision, it's the mass of the first object times the velocity of the first object plus the mass of the second object times the velocity of the second object. Then after the collision, that has to equal the mass of the first object times the velocity of the first object plus the mass of the second object times the velocity of the second object. A very important point that's tested on the AP exam is that momentum is conserved in all collisions. Okay, so here's a little schematic I set up to kind of illustrate this. A 4 kilogram bowling ball moving at 4 meters per second to the right, so you can see that over on the left hand side of the diagram, collides with a 2 kilogram bowling ball moving at 3 meters per second to the left. Now, one thing you got to realize, you have to assign a positive and negative direction. So we're going to say the positive direction is to the right and the negative direction is to the left. You could have reversed it and end up with the same answer in the same situation. After the collision, the 4 kilogram ball is moving at 2 meters per second. You can see that on the right side, the right diagram. That's the after picture. How fast is the 2 kilogram ball moving and in which direction? Okay, so what we're going to do is we're going to multiply 4 meters per second over on the left times 4 kilograms. That'll give you a momentum. That will give you a momentum of 16 kilogram meters per second. Now the second bowling ball, the 2 kilogram bowling ball, is moving 3 meters per second to the left. So that means it's a negative 3 meters per second. So that's going to give you negative 6 meters per second. So the total momentum of those two bowling balls is 16 plus negative 6, which will give you 10 kilogram meters per second of total momentum before the collision. Now, conservation of momentum says that that 10 kilogram meters per second of momentum is going to be conserved. So the bowling balls will have that after. So now we can figure out the 4 kilogram bowling ball is moving at 2 meters per second times 4 kilograms is 8 kilogram meters per second. So that 8 kilogram meters per second plus some unknown amount of momentum has to equal 10 kilogram meters per second. So that means that number there must be 2 kilogram meters per second. Now working back up, our unknown velocity times 2 kilograms is going to equal 2 kilogram meters per second. Therefore, that unknown velocity must equal 1 meter per second. And since it's a positive one, it has to be moving to the right. That was kind of obvious since the 4 kilogram bowling ball is moving to the right. There's no way the 2 kilogram could have been moving in the other direction, but sometimes it's not obvious what the direction is. Okay, so that's how you do that, and this is called an elastic collision because when bowling balls hit each other, they don't bend, they don't deform, they just bounce right off of each other. That's an elastic collision. Okay, now let's look at an inelastic collision. An 8 kilogram train car moving at 5 meters per second to the right hooks onto a 12 kilogram train car that is standing still. After they hook together, are they moving? How fast? And which way? So we go ahead and start the problem off just like the last one. 5 meters per second times 8 kilograms is 40 kilogram meters per second of momentum. The 12 kilogram train car is not moving, so therefore it's 0 times 12 is 0 kilogram meters per second of momentum. When you add those together, you get 40 kilogram meters per second of momentum. Again, conservation of momentum says that that's going to be the total momentum after they collide and hook together. So now you can treat them as a single 20 kilogram train car. The 8 plus the 12 are basically one train car now. They're hooked together. So is some number of meters per second times 8 plus 12, which is 20, equals 40 kilogram meters per second. So that question mark has to be 2 meters per second. And since it's positive, those train cars are moving to the right. Okay? Again, that's called an inelastic collision. What is a collision? A collision is when one object strikes another object. There are two types of collisions, elastic and inelastic. An elastic collision is one in which two objects collide without sticking together or changing shape. Think of two bowling balls colliding. An inelastic collision is one in which two objects collide and stick together or change shape. Think of the two train cars in the previous example hooking together, or two lumps of wet clay sticking together when you throw one at the other. So conservation of momentum, and this is going to be heavily tested, so we'll do a lot of problems on this concept. Momentum is conserved in both elastic and inelastic collisions. Conservation of energy, which we're going to talk about in the next couple of lessons. Energy is conserved in elastic, but not in inelastic collisions. And there's all kinds of ways that the AP can test you on those concepts, and they will. All right, so that takes care of this lesson on momentum, and we'll move on to energy, work, and power.